Thank you for keeping the introduction short. Thank you for the invitation. I would like to thank Cindy for inviting me here. It has been an absolute pleasure. It was an especially wonderful pleasure is to go into my room, open it up, and see that I have a 4-bedroom suite with a butler, and that I have a disco ball hanging over my bed, and then I go into the bathroom and I don't have a shower, but it's a waterfall with a mermaid, and I'm like, whoa, this is awesome. What did Glenn get? A tent, yeah. He got a cardboard box with an LED, yes. All right, so I am here and I am ready to cause some damage. So there's a part of me that feels like I need to apologize because when I saw the number of hands go up, for those of you who are here for the first time, I'm thinking, wow, you have no preparation. You have no background. The presentations that I've given before are all going to have to be practically talked about in a certain sense because this talk has never been given before. The talk that I have given, and the one that has kind of set me apart from most other speakers, especially entomologists, has been the Brix presentation. Maybe you've seen it online, maybe you've seen it here in Back to Your Roots in the past. This Brix presentation has caused a lot of hubbub. And that's a nice way of saying crap, okay? So when you are giving a presentation of that sort, a lot of questions come up. Part of the reason why the questions come up is because I have 1 hour. The presentation is about 1 hour long. I am introducing a new concept of Brix and plants and insects that no one is really familiar with. And when you do it in an hour, you cannot do it justice. So because of that, you get a lot of questions. Oftentimes they come after the presentation. Sometimes they come online. Sometimes they're accompanied with swear words. And so because of this, I have had to come up with a second presentation to start answering questions on the first Brix one. I then came up with a third presentation that also further explains this Brix phenomenon. This talk is the fourth that I have come up with. So when I was talking with Cindy, and I said, you know, the presentations that I've given before, which one are you looking for? And so I talked briefly about the fact that I was in the process of building a fourth Brix presentation. Keyword, I'm not done yet. And so I was hoping she wouldn't bite. I was wrong. Cindy said, that's the one. She goes, tell me a little bit about it. I said a few sentences. She goes, that's the one I want. And I thought, okay, this is the fourth Brix presentation. Some of you have probably seen the first, maybe even the second, and maybe even the third. But you're all going to get the fourth together right now. Because the question that keeps coming up, the number one question after my presentation, how do I raise Brix? That's what everyone wants to know. They want a magic bullet. They want me to tell them, love potion number 9. They want me to tell them, just a little bit of Mountain Dew will take care of it. They want me to tell them, you use this product, and the magic is going to happen. And that's what they want to hear. How do I raise Brix? The answers to the question of how you raise Brix are also found in lowering Brix. It's sometimes not a question of what you're putting down in order to raise it. Sometimes I just need you to stop doing what you're doing because you're lowering Brix. Therefore, this presentation, which originally was supposed to be something like how to raise Brix or raising Brix, now out of necessity has become raising Brix, lowering Brix. Because you need to understand the process and why plants are doing the things that they are doing, and how insects are now choosing at what the level of Brix is as to whether or not they're going to come in and feed on it. So this is the chosen title. We're here at the Back to Your Roots Conference, and that's where I am, Dykstra Laboratories in Gainesville, Florida. I grew up in Rochester, New York, and so I'm very familiar with Canada. I mean, we went to Toronto all the time, among other things, but after going to Cornell, I spent the first 22 years of my life in the Northeast, and I realized I am so done with the cold. So I came down to Florida, got 2 more degrees down there, and then I decided to stay. And so Florida is where I have been ever since, still in Gainesville, which is where the University of Florida is located. And that's where my laboratory is. I've been doing it now for a quarter of a century, and for reasons that are still not clear, Cindy keeps inviting me back. Insects only feed upon food that is considered unfit, nutritionally poor, dead, or dying. No exceptions. This is for the benefit of those of you who are here for the first time. Maybe you haven't seen this before. I sure know you didn't get this in the university. I didn't get it in any of my 3 entomology degrees. And I'm pretty sure you guys didn't get it in any college course that you may have taken. You might have heard it outside college, maybe not. But I need to come up here now and let you know that insects are not competing with us. Their job is to eat crap, sometimes literally, if it's a dung beetle, in other cases, simply a poor or unhealthy plant. So that's why this is up there. And I put it in big words in order to hit home this point. In the past, I have used this chart. This chart was part of the first presentation, and I'm going to repeat this chart because this is near the end of the first presentation, so that you're all on the same boat right now. I'm going to start filling it in. There's probably no reason to take pictures, not just yet. So I've got the leaf Brix chart up here, where I crush a leaf and determine, through a sap analysis, try to get 2 or 3 drops out of it, how healthy the plant is, because I know that by testing Brix, which is sugar, I'm indirectly testing photosynthesis in the plant. If the plant is healthy, it's going to have more sugar. And if it's not healthy, it's going to have less. So if I'm dealing with a 1 to 2 Brix plant, force feeding is necessary. These plants do not do well. They do not survive unless you force feed them. So I've mentioned in the past, a golf course, especially on the greens, is where you find 2 Brix and below. Many house plants are certainly in that range. Out in the wild, you usually don't see them too much because they get picked off. But in the second stage, from 3 to 7 Brix, these plants, they have a fighting chance. They're not doing great, but they're doing okay, and they got a chance of making it through. A lot of our plants that we are raising right now are in that 3 to 7 range. Something does interesting happen during that time. At about 6 Brix, the plant secondary metabolites increase. What are the plant secondary metabolites? They add taste, flavor, color. In some cases, they add repellency if it's insects that are attacking the plant. These are the plant secondary metabolites. They begin in earnest at about 6. That doesn't mean they are there completely. That means they are starting to build up. So what are you trying to say, Tom? Are you trying to tell us that anything below 6 Brix tastes like cardboard? Yes, that's exactly what I'm saying. So if you ever had a fruit or a vegetable that tastes like cardboard, I can tell you what the Brix was in advance. And if you've ever seen or tasted a healthy fruit or vegetable, you are indirectly, without knowing, that you're eating a higher Brix fruit or vegetable, and then the case may be. So that's what happens in the 3 to 7 range. In the 8 to 12 range, the plants have what I call a proverbial sword and shield. They're able to defend themselves against insects, for example. They're tougher. They look better. In some cases, those plants between 8 to 12 Brix look perfect. To the unaided eye, they can look perfect. But if you do some testing, such as the Brix readings, which you can do in a matter of minutes with the right equipment, then you can determine that. And there's your Brix refractometer. Thank you, Glenn, for not taking it yet. How much does it cost? And you can get some for less than $100. Digital ones will run you 150 plus, but you can get a quick test and find out where you're at. Something magical happens. Water retention abilities increase drastically from 8 to 9 to 10 and to 12. Why? Because as Glenn was just mentioning just before this, a lot of the sugar, about half, give or take, certainly it can vary between 20 to 70%, but about half of the sugar that the plant is making in its plant body is being exuded through the roots into the soil to feed the microbes. And sugar is hygroscopic. Sugar absorbs water. That's one. In addition, the sugar is feeding the microbes, which means you have more microbes in the soil. More microbes means all of those microbes are taking a sip of water. And so if you have 200 million microbes in a teaspoon, that can be a lot of water that they're sipping. That is water retention. Yes?
Do you have water retention in the plant and in the soil? Or?
Absolutely you do. In the plant and the soil. And any organism else that's in there. There are some other insects in the soil too. Same thing. Same thing. If the water is there in plenitude, it will be in the plant, it will be in the soil. Everybody is going to be much happier. So your water bill definitely goes down as you get closer to 12. It is at this point that insect resistance begins in earnest. 8, 9, 10, 11, 12. You get more and more resistance from pests as you go up this Brix reading. Below that, not so much. You're going to have a lot of insects attacking your plants if you are at 6, 5, or 4. These plants over here, 12 to 20, I usually don't go much higher than 20 because you almost never get above 20, on the leaves. The fruits, sure, lots of fruits can get to be over 20 Brix, lots. But the leaves almost never break 20, so that's why I've stopped it here. These are objectively healthy. Objective means not subjective. Everyone will look at this and using any test you want, it will tell you these are objectively healthy plants. There's no argument to be made. That's what objective means. And obviously they can get to be a little bit healthier if they're at 12, 13, 14 and above. Food is now produced. Food that you can eat. Food that tastes good. Food that gives you life. Food that gives you a long life so that you can live into your 70s, 80s, 90s, and beyond. That's the type of food I'm talking about. Real food is now being produced. It is now fit for human consumption. And the side effect, no insects, no disease. You can take pictures right now. I'm finished with this particular one. So you can see, as you move through the Brix chart, how much information is being given you by taking a Brix reading, which is so easy. I've been doing this now for over a decade right now, and it is so easy to disprove me. It is so easy for someone to go out and spend a little bit of money and show me that I am wrong, dead wrong. And I'm still waiting for that to happen. Because I'm telling you, if it hasn't happened yet, it's probably not about to. This is becoming more and more established. And therefore, this is a truth that I am now talking to you about. And I've gone to the next step. Why? Because I'm an entomologist. So I have to bring the insects into this. On the charts, it was very difficult for me, being an entomologist, when people were coming up to me and talking about the magical number of 12 Brix. They say, well, it's above 12 Brix, you don't have any insects. If it's below 12 Brix, you have insects. And I'm thinking like, well, yes, but isn't there more to this? Please tell me that there's more. There's got to be more than this. Yes?
Based on what was said saying that you can't eat a healthy insect.
Can you eat a healthy insect? Yes. If you eat a healthy insect, you will also gain some health associated with the insect, because the insect will process crappy food and turn it into more healthy food, which makes the insect healthier than the plant. Does that answer your question? That's not the answer you wanted, though.
Well, if insects eat healthy food, so if they're eating unhealthy food, how can they get healthy?
Oh, because they biochemically make it into healthy food. We do this all the time.
Because we're supposed to start eating grasshoppers, right?
That's what people are saying right now, but I wouldn't do that if I were you.
I seen it.
Yeah, they talk about a lot of different things, not just the grasshoppers that need to be eaten. No, you do not need to eat insects. There are a lot. You're welcome. There are a lot of other foods that we can eat that we process much better than we do insects. All right. So I've got 4 different insect groups up here. The aphid group, not just aphids, but the aphid group includes aphids, scales, includes the phylloxerans, and includes the mealybugs. Those are the lowest level insects. By the time a plant gets to, let's see, 6, they start falling off the plant. They start losing interest in the plant. By the time you get to 7, even more. By the time you get to 8, you don't have any more aphids or mealybugs or scales. They're all gone. Then other pest insects come in. And so we have the sucking insects that are not aphids, mealybugs, and scales. These are the leaf hoppers, the plant hoppers, frog hoppers. This includes the lanternfly, which is actually a bug. This includes any stink bugs, any insect that is sucking the material from the plant is a sucking insect. They prefer things a little bit healthier, and they will start falling off the plant or leaving it. Once they get to 7, 8, and by the time you get to 9, there are none left on the plant. At that point, other pest insects will come in. We now have the chewing insects. The chewing insects includes the Lepidoptera, the butterflies and the moths, the Coleoptera, the beetles. It will also include the Diptera, which are the flies, other insects that are chewing on the plant. They will start to lose interest between 9, 10, and 11 Brix. The grasshoppers, they can handle the healthiest stuff. Grasshopper group includes the grasshoppers, the katydids, the crickets. These insects will feed on healthier crops, but they still need an unhealthy plant. Can a plant get too healthy for grasshoppers? You better believe it can. All insects in that second slide are feeding upon unhealthy food. That hasn't changed. I'm just talking about degrees of unhealth. Alrighty, so here's the slide that sold Cindy. Okay, so this is a new slide. You have not seen this one before. If I am taking the measurements of a crop, the crop can be apples, cotton, soybean, strawberries, corn, you name it. Any crop that is being raised by a farmer. I can go out into a field and get a Brix measurement, a leaf Brix reading from that plant. What am I going to get? I'm sure you'd love to know, and I'm happy to tell you. But 80% of the time, these readings are going to be between 2 to 10. 2 to 10. Does this mean I'm not going to get readings below 2? No, I didn't say that. I didn't say 100%. I said 80. So I can definitely get readings below 2. Are you saying they're not going to be any better than 10? I didn't say that. You will find plants higher than 10, certainly at 11 or 12. but 80% of the readings that I get are between 2 to 10. The other 20% are going to be on the fringe of that. So I've just saved you a lot of time. Some of you are probably thinking, I'm going to go out and disprove Dr. Dykstra. I'm going to go to refractometer. I'm going to start figuring things out. I'm figuring some of this stuff out for you. Now, what about the other plants? Most of the plants. 95% of the plants on planet Earth. What about the pine trees in a forest? What about some of the plants that are in the middle of nowhere, or maybe in your front yard, assuming you haven't done anything? What about those plants? What about most of the plants that are out there? What do they get on a Brix reading? You would like to know, and I would like to tell you. 80% of the plants in nature will be between 8 and 18. I'm going to give you a few seconds to let that sink in. And you're thinking, wow, there's very little overlap. Yeah, with the exception of 8 to 10, there is very little overlap between them. And so we've got a problem. Or some of you might say, I'm not sure if we have a problem. Isn't this like, evidence for God? I would say, yeah, God seems to be doing a better job of raising plants than we are. And so when the question comes up, because no one's ever seen this before, how do I raise Brix? There's a part of me that says, why don't we look to see what God is doing with 95% of the plants in nature? And then we can start to come to some conclusions as to what we might be doing wrong with our crop plants. Because 8 to 18 is as it is. Does that mean it's not going to get below 8? Certainly I've tested plants out in nature below 8. You can find them. They are slowly being picked off by insects and disease. Can you find higher than 18? Yes, it's rare, but it's out there. Yeah, you can get 19 or 20 on some of the leaf readings that are out there. It is absolutely true. But most of them, 80%, there is very little overlap between them. And so Cindy just loved this, and she goes, oh, I so want you to discuss this. And so I have now gone down this path. I have to follow up, because now there has to be some knowledge as to what we're doing to raise Brix and to lower Brix. And so if you are going to look at this question objectively from a scientific standpoint, where do you begin to look at why this disparity exists? And I'm going to begin with the vertical jump. That's where I've decided to begin with, and that's where we're all going. Most people on a vertical jump, standing right where you are, most people can jump between 3 to 24 inches, the distance between the floor and your feet. Not talking about very tall people with your head. I'm talking about your feet. Most people can jump between 3 to 24 inches. 24 inches, I'll admit, most of the athletes. Many of the athletes can go 24. They can go even higher than 24 inches. But most of the population is between 3 to 24. So if I'm taking a look at this, I would say certainly among the athletes, the volleyball players are among the best. They do have some of the best leaps, and many of them are above 24-inch as far as their feet are concerned, above the ground. Very impressive, very impressive. So if I were to test one of these athletes, if I were to bring in one of these athletes in order to test them, let's just say that a particular athlete I test and has a 24-inch jump, okay, for the sake of argument. I would say, thank you very much. I'll move on to the next person. The person goes, whoa, 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 whoa. I'm not done yet. I said, I want you to test me again. I was like, okay, I think we're all set though, but you wanted to go a little bit further? He goes, yeah, I do. So he walks over and he grabs a 16-pound bowling ball. And then he goes over and he grabs another 16-pound bowling ball. And he's holding them. I'm I'm looking at him. He goes, test me again. I said, I don't think this is going to work out well. And he says, go ahead, test me. So I test him. He does not break 24 inches. He's considerably less. He has added now 32 pounds. That's 16 times 2, by the way. I'm doing the math for you, so you don't have to think too hard. He is no longer able to jump 24 inches. And I say to him, okay, I'm not really sure what the point of this is. This doesn't look like a good idea. And I said, we need to get your jump back to 24 inches because that's going to make you more competitive in your particular sport. And he says, I got an idea. And I said, all right, I'm listening. He goes, anabolic steroids. I'm like, what? He says, I take anabolic steroids, I'm going to build up my leg muscles, and I'm going to get bigger, and I'm going to be able to jump higher. I said, okay, sure, that could work. You should know it's going to take some time, probably at least 3 months of the anabolic steroids, not to mention the fact that they're illegal, and we'll give you small testicles. But other than that, this is something that we could pursue, but is there something you could do that's a little bit quicker in order to get your jump back to 24? It says quicker. Yeah, quicker. Trampoline. And I'm thinking, trampoline. Trampoline would work. That's something you can do. But the problem with the trampoline is that you will have to carry this around with you wherever you're going in order to keep your jump at 24 inches. So I just don't think that's going to be practical. He goes, yeah, you're right. He goes, I got it. If I get 2 of my fellow players to lift me by the shoulders up when I jump, and I say, you could probably go 24 again if you do something like that. But now you're troubling someone else. Plus, I'm trying to test to see how far you can jump by yourself. And now you're going to be getting your friends to do it? This isn't working at all. This isn't working. And then I say, if I may, would you consider letting the bowling balls go? I was like, why would I do that? It's just a thought. I think this would be the fastest thing. It's like, I love my bowling balls. I'm like, I'm sure you do. I'm sure you're a big fan. You probably go to a league every single weekend. My high is a 279. That's great. And you're probably trying to hit a 300. I get it. I get this. And you're building your strength up right now. But we are at a point right now where I think it would be best to simply drop the bowling balls in order to keep your vertical jump up high. And in that short analogy, I have just described the rest of my presentation. Nice colors. I like bowling, by the way, too. So, what do you begin with? Where does it begin? Where does it begin? And I would say if you're trying to raise Brix, where does it begin? It begins with that 4-letter word that starts with the letter S. And 8 out of 10 of you would know what that word is. And because our former speaker works for Soil Works, and because we have Back to Your Roots Soil Solutions, everybody knows what that 4-letter word is. It's the most important thing. Agronomists talk about it all the time. It's soil. But that's not the first thing. What occurs before the soil? It's the seed. It always begins with the seed. Always. I don't care what kind of soil you have. You must first establish that you have healthy seed. Because if you don't, you're going to be in a world of hurt if you're looking to get a high Brix plant. Because there's genetics involved. So if I, at my age, decided that I wanted to make the Olympic team in the 100-meter dash, many of you would laugh at me and say this does not seem realistic, not to mention your age, but many other factors too. But I want to go ahead and train that way. And you would say, you don't have the genetics. That would be a truthful statement. And because I'm a scientist, that might even resonate with me and turn me away from my wayward ways. But I don't have the genetics to do it. If you don't have the genetics, you are not going to be able to produce a high Brix plant. Well, That's all fine and good, Tom, but how do you measure a seed? I mean, we've got seeds that are coming from crops grown. We have seeds in nature. Is there a difference? Well, yeah, there's going to be a difference because the seed constituents, there will be some sugar in the seed, a little bit of energy, not a lot of sugar in a seed. There'll be proteins in there for a nitrogen source and some key lipids, as well as some of the micronutrients, calcium, potassium, magnesium, phosphorus, boron, and so on and so forth. If the seed is healthy, you will have all of the necessary nutrients that the seed needs to start the process. But there's a problem. It's glaring. Because seeds that are coming from our crops are all compromised. How do I know this? Because if I am ugly, you shouldn't be laughing at that, and my wife is ugly, you better not laugh at that. What are the chances that me and my wife will help produce ugly kids? Pretty good chance of that. Ugly mom and ugly dad, ugly kids. Maybe we'll get lucky. I do have 7 kids, so the odds are maybe I can get one of them that's reasonably good looking. But the genetics are there. I can't hide the genetics. I am who I am, and I'm contributing to my children. My wife is the way that she is. She is contributing in her own way too. And ugliness has a tendency to move through genes. And it's the same thing with seeds. If you have seeds that are coming from 4 Brix plants, how healthy do you think the seeds are going to be? Honestly, how many of you have even thought about this before? So if you've got low Brix plants and you're buying your seeds and they're collecting them from low Brix plants, you've got low Brix seeds. Not that you can test them, but when they grow up, you will see that they're not going to give you the results that you want. On the other hand, we're going to have relatively healthy seeds coming from them in nature. And how can you tell whether or not the seed is healthy or not? Emergence rates is a key factor where you don't have to get inside the seed. You don't have to probe the seed. And when you do that, you should be expecting 95 to 99% emergence. If you have seed with a 95 to 99% emergence, that is very good evidence, not conclusive, but very good evidence that the seeds are healthy. Is this what you are getting right now? Question.
Tested on soil or tissue?
Any way you want. But soil generally, because the farmers will put the seed in the soil, and they will notice that not all of the seeds are emerging. I can tell you why. I just told you why right now. And so yes, so if you're putting out one seed at a time, you will notice gaps. And some of you are thinking like, well, what if it's close to 95? Is close good enough? Because if you're at 90% emergence rates, that seems pretty good. But I can tell you, you do have unhealthy seeds if you've only got a 90%. You're spending money on this. And 10% of your seeds aren't even emerging? And some of you are saying, well, I'm actually not at 90%. Some of you get as low as 40. Some of you get as low as 40, where you're putting out a lot of seeds and you don't get a lot of plants out of it. So the seed, this is where it starts. This is not the end all, but it's where it all starts. If you continue to buy crappy seeds, you will continue to get crappy plants. And then you will continue to get insects who will come in order to eat your crappy plants. And then you will go out and get various insecticides in order to kill those crappy insects that are attacking your crappy plants. And then you realize the bottom line that Mr. Ravenberg was talking about is now being compromised, isn't it? Healthy seed contains all of the necessary micronutrients. If the plant is healthy, It will move in the copper. It will move in the necessary boron. It will move in the manganese. The seed will have everything that it needs to start. Not enough to grow big, you understand, because the seed is very limited. It's just enough to get it started. And if you've got a good start, you've got an excellent chance of hitting 14 Brix and above. So it begins with the seed. It follows with the soil. And that's where the soil names come from, because we often like to focus on the soil. And it's important, and it should be important. I mean, it's in a lot of the names of the companies that are around here, as I just mentioned. So I'm not saying it's not important. I'm just telling you it's not first. That's all. So at best, it's second. So it follows with the soil. So we have types of soil. The classic soil that's out there is sand, silt, and clay. Those are the three common types of soil that we are all familiar with. If you have loam soil, that's just a combination of the sand, silt, and clay. And so soil is often broken down into these categories as if this is highly meaningful, because it's not. This just really talks about the coarseness of the material. Sand, relatively coarse. Silt, which is what you might find on a riverbed. And clay. We got a lot of clay soil up in Georgia, which is just north of me in Florida. We have these three types, and a loam is obviously a combination. But this is just describing the coarseness of the material. There's a lot more to it than that. The consistency is something. And then we have another type of soil, which is rock. Not something that people mention, but it should be mentioned now, because this is actually an important point of getting healthy plants. But we have plants that use rock, just rock, in order to grow. I was like, well, I've never seen anything like this. It just sounds totally ridiculous. They are known as lithophytes. Litho means rock, phyte means plant. Lithophytes are plants that grow in or on rocks. They survive on a diet of sunlight, rainwater, and the minerals they extract from the rocks they inhabit. This goes to show you how important minerals are. This is how important it is to show you how important mineralized soil, not just your sandy soil or your silt soil, but mineralized soil. Because all you really need, in some sense, is minerals, and many of them will grow. If you've never seen anything like this, you think this is ridiculous. I've never seen roots that are visible, totally visible, wrapping around a rock. But this is what many of the lithophytes do. Granted, they are slow growing. They're not the fastest growing plants in the world, but they can survive just on rock. They digest it, secrete a few acids in the roots, take a little bit of the nutrients from the rock, and they are strong. They are tough. They are high Brix. Get an axe and start trying to get down some of these trees that are growing out of rocks. You'll have some of the highest mineralized plants you have ever seen. Not to say that this is the way to go, but I sure am trying to hit home a point that I hope all of you are getting right now. You've got trees, northern white cedars, growing straight out of the side of a cliff. Very little soil, sometimes zero, sometimes close to zero, simply getting their nutrients from rock. And here we are, some other examples too of the same thing. I mean, it's quite dramatic to see something like this, but it goes to show you how important minerals are to the soil. And it's not just important getting a soil test without understanding the minerals that are available, even if they're not in the plant yet. So we have other things to consider, as we've talked about already. The type of soil has its place, no doubt about it. But now we have microorganisms in the soil. We need bacteria, we need fungi, and then we also have the big stuff, like the nematodes, microarthropods, and earthworms. They are all contributing to soil health. And they are moving, especially the bacteria and the fungi, they are moving these nutrients into the plant. Some of you, maybe you're hearing this for the first time. I'm pretty sure you're wrong, Doc. Plants put out roots in order to pull up nutrients. They do this themselves. No, they do not. It's the microbes that are feeding the plants. The roots only taking up that which becomes available by the microbes. You need to have the microbes there, and you need a lot of them. 200,000 in a spoonful sounds like a lot. It's not. 20 million, now we're talking. 100 million plus, those are some of the peat soils that we have in Florida and some of the swampy areas. We've got a lot of organic matter, but you just need a lot of them and a diversity in order to get these minerals chelated and into the plant to make it, the term, bioavailable. Once they are bioavailable, these microorganisms in the soil will be able to get these nutrients into the plant. That is the importance of soil. So we test all of these things. We do want to know the consistency. It has its place. But we also want to know how many microbes we have in there as well. And then we also test to see what nutrients are available, because this tells us how much could potentially get into the plant. These are the differences between a high Brix plant and a low Brix plant. You could say, well, if I don't have the nutrients, low Brix, bingo. If I don't have the microorganisms, I have low Brix, bingo. If I don't have the right soil, I could have low Brix or high Brix, true. That's the least important thing in this particular slide to do. How do I know this? I mean, look at the palm trees in Florida. They're growing in pure sandy soil, and they do really well. They don't grow very well in other parts of the country and in other soils, but they do very well in sandy soil. So every plant has its place. So why are the microbes so important? Well, because, as I just told you, they're moving nutrients into the plant. The nutrients are the minerals. I just got finished telling you how important the minerals are to lithophytes. So you cannot be killing the microbes, because when you spray an herbicide to take care of a weed, you're also killing microbes. When you spray a fungicide to kill fungi, you are also killing microbes, different microbes than the ones you killed as an herbicide. And insecticides, sure, you're trying to kill the insects, which you really shouldn't be doing, because they are only indicating to you that you have an unhealthy plant. You are also killing microbes with them too. Does the story end there? Absolutely not. Because I'm an entomologist and I'm trained in pesticides, and I know that there are chlorinated hydrocarbons and organophosphates, sometimes called OPs. And I know that there are carbamates, pyrethroids, sometimes called synthetic pyrethroids, as well as neonics or neonicotinoids. And all of these insecticides kill particular microbes, and they're not the same ones. Neonics do not kill the same thing as carbamates. So if you are being told by the university to switch between different modes of action of your insecticides in order to stave off resistance in the insects, and you are. I know the professors. I know some of the extension agents. I know that this is what they're suggesting. Then you are doing a very good job of cleaning out your soil of microbes. Because oftentimes when you're spraying the insecticides, you set up a situation that is favorable to fungi, which means now you're going to need a fungicide. And when the soil gets bad, weeds come up to try to improve it. And so therefore you have to use an herbicide, and you get caught. And when you get caught, you're doing a fantastic job of cleaning out the microbes. And when you don't have the microbes, you've got a low Brix plant. And you measure it for the first time, because you're so excited to go out and get that refractometer, because Dr. Dykstra said to get one. And you see that first reading, and you're hurt. It brings a tear to your eye. You're like, I was so hoping for like 14, 15, maybe 135. I don't know. I just wanted something big. But you see the single-digit number, and it hurts. You are doing this to yourself. I'm not doing this to insult you, but I am doing this to wake you up. So how do you raise Brix? I'm telling you to stop doing some of the things that you may be doing. I am telling you to put down the bowling balls. Salt, that's another big one. Salt's a big problem. We've known about this for a long time. It's there in the Bible in Judges 9. And Abimelech assaulted the city all that day and took it and killed the inhabitants. Sorry about that. I realize this is a family show, but he did what he did. And demolished it so that he sowed salt in it. Sowing salt is to make it fit for nothing. They knew, because this is dated to about 1050 BC. So this is 3,000 years ago. We knew that putting salt on a field was bad. So we conquer the enemy, and then we sow salt on the fields because we knew that they weren't going to be able to raise crops. So what are we told to do nowadays? We are told to put on salts. So we have high salt index fertilizers. Most, not all, most of the NPK fertilizers are high salt. Why? It's done to stabilize them. Why do I need to stabilize them? Because they have a tendency to explode. If you've ever heard about the fertilizer plants and the explosions that they have, we realize that it's very unstable. So they put it into a salt mixture, usually in a dry formulation, in order to make it a little bit more stable so that you can spread it. So you're putting salt on your fields. You put on too many, you can overcome the biology and actually kill it outright. We also have fresh manures, not the composted ones, but fresh manures, generally speaking. If I'm going to sit down and squat on stage, I'm going to tell you there's going to be a lot of salt coming out my back end. And that's going to be the same thing with a cow, same thing with sheep, same thing with goats, same thing with everything, because a lot of that fresh manure, by design, has high salt in it. So to take the fresh stuff and put it onto the field compromises your field. You say, well, it could be broken down and used as a nitrogen source. Yes, eventually, but not immediately. And we also have salt-based poisons. Many pesticides are also salt-based for the same reason that they do for the NPK fertilizers, is to stabilize them. So you're putting salt on if you're using pesticides, you're putting salt with NPK fertilizers, and when your soil gets decrepit and old and in trouble, you then have to put on more of the same. And then you test your plants for the first time. And 80% of the time it's between 2 to 10 Brix. And you see where I'm going with this right now. We also have irrigated water in some areas, areas with high groundwater. High groundwater, that's us in Florida. When we have a hurricane come through, the groundwater can come up all the way to the surface and will dump a lot of salt on the surface because all of that salt that the farmers in Florida have been doing are in the water, and as soon as it comes up, it spreads a very visible white crystalline substance, salt, on the surface. It's usually gone pretty quickly. We get a good rain, it goes back down into the groundwater again. But you can see some of the problems that we are developing with salt. So related to that is irrigation. I want to talk about irrigation right now. Irrigation, here's irrigation. Drip irrigation is very popular right now. It's very popular among the desert Southwest, Southern California, New Mexico, Arizona, Texas, among other places, Colorado, where things are very, very dry. They use drip irrigation. Why do they do it? It's a rhetorical question. I know why they do it. It's because they're trying to conserve water. Drip irrigation is a problem. I have been testing it relatively heavily. It does not give healthy plants. One of the problems is that drip irrigation usually causes the water to go to one area and you create a ball of roots. That's the first problem. Roots want to spread and find what they can. Instead, you dig up the plants and they have a ball. That's one of the problems. Another problem with the drip irrigation is that the leaves above remain dry. They also like water. They do like to be rained on every once in a while. It's not a bad thing to get a leaf wet. We were actually told this 20 to 30 years ago. I couldn't believe it. I'm thinking, wow, if leaves getting wet is bad, how dangerous is rain? We need to stop this whole rain cycle right now because we're killing our plants. The drip irrigation, and here's another example of it right there. We got it right there where it's just kind of dripping down from above. What happens is with drip irrigation, you are given the minimum water that you need, and they sustain it. So you get the minimum amount. Usually you have sensors. And that minimum amount, once it gets below that, more water will be dispersed through the irrigation system, through drip irrigation. So when you continually get the minimal amount of water, you create a problem for your plants. What are plants used to? The plants are used to scarcity and then rain. And when the rain comes, whoa. If you've been out in your field, and I'm assuming all of you have, look at the changes that happen when rain comes down. It's amazing. It's a lot better than irrigation. That's because rainwater is healthier, and when it falls, there happens to be a lot of it. And when there's a lot of water, the plants do something. Simultaneously, open up all of their stomata. And water comes up quickly. And when it comes up quickly, it is able to pull up heavy minerals, calcium, manganese, copper. All of these heavy metals can be brought up if it's done quickly. If you have drip irrigation and water is only moving up slowly, we have found severe calcium deficiencies can be corrected just like that with rainwater, just like that, within 24 hours. Because we do the soil tests and we see the calcium's in there, but it's not getting up into the plant. And that's because we are giving them the minimum amount. We need a lot more water. And so if we don't have it, then irrigation needs to change. So you're irrigating 7 days a week, maybe you should go down to 1. Because I can assure you a plant will be fine if it goes 7 days without rain. We've been doing it since the beginning of time, since the Garden of Eden. They can do it again. Yes, you will have to go heavier. Well, I don't want it evaporating off. Then do it when the sun isn't coming up. Because I can tell you right now, a good dose of water is better than a lot of little doses of water, especially when you're trying to get minerals into your plant. Okay. So I've said enough about drip irrigation. That's contributing to low Brix. Center pivots. Here we got some center pivots going on. These are obviously going to be much improved over the drip irrigation. Wheel line sprinklers, this is what we have in Florida. Everywhere I go, these are very, very common. They're not on a pivot. Most of the time, they're just going over square fields or rectangular fields, and that's how things are usually done. But it's very similar to rain, and therefore it has more health benefits than you will find with drip irrigation. We have found this scientifically, and therefore I'm imparting this knowledge to you so you don't have to go through this. If you have drip irrigation and you spent tens of thousands of dollars to put it in, keep it, okay? It still has its use, but you're still going to need to throw in a lot of water every once in a while, and you may have to do that through an alternative. So I don't want you to think you need to go in there and rip everything out. But I'm telling you, if that's all you're doing, you will have low Brix plants. Rainmaker, they've already discovered this already because there's lots of oxygen in rainwater. And as Glenn mentioned, we need oxygen in the soil. We need oxygen to move the minerals up, and there's a lot of oxygen in rainwater. So it was sooner or later there would be a company that would come out and realize, oh, why don't we simulate rain by putting in oxygen? They even put in some nitrates because lightning can put nitrates into rainwater too, which also has a limited benefit to that. So we understand the importance of rain. Companies out there are now beginning to realize this too, even though this company is 20 years old. And so these are things that help compromise your plants. What's next? All right. You get sick. What happens? Well, right now, this person looks like they're a little cold. You got a blanket on them. Probably because they are cold. Usually you get a little cold when you're sick. And sometimes you just want to go to bed. And you'll cuddle up underneath the covers because you're still cold and you're sick and you're tired. And you don't want to get up. You don't want to walk around. How many times have I been sick where I feel so bad that I don't even want to go to the bathroom because I have to get out from underneath the covers in order to go to the bathroom? That's how sick some of us have been. So this is a natural process that the body has learned to heal itself from. The body heals itself through these various proteins. These various proteins include some, long words like eosinophils, but it's the lymphocytes that I want to focus on. These are the white blood cells that help fight viruses, help make antibodies, and are usually the things that we associate with sickness because our lymphocyte content goes up. We can have 10,000 in a microliter, which is 10 billion lymphocytes in a liter. So in a 2 liter of Mountain Dew, in that 2 liter, I can have 20 billion lymphocytes. That's how concentrated it is when you get sick. These are proteins that are not made unless you get sick. But when you get sick, they have to be made. And because they're made, that causes you to get tired. You have to produce all of these proteins, every single one of them, and they're usually composed of multiple proteins. And you have to go through the process of translation, transcription, to make messenger RNA, to make transfer RNA, to make ribosomal RNA. All of these proteins need to be made in order to make those lymphocytes. You get tired when you are making that much protein. And so all of these proteins need to be done in order to eventually produce your energy source, ATP. That's what gives you the energy in order to fight off disease. And when you're sick, it can be tiring. Same thing with drugs, pollutants, and pesticides. In order to get them out of your system, the plant now, we do the same thing. We have 3 main types of detoxification enzymes, the esterases, the cytochrome P450s, and the glutathionase transferases. And there are many types of P450s. These are just the groups of them. But all of them, without exception, are proteins. So when you are sick, you're making lymphocytes and you're tired. When you have drugs, pollutants, or pesticides, you will also get a little tired if you are exposed to them because you need to detoxify them. This is the natural process in humans. And the same thing happens in plants. Plants can get sick too. So where am I going with this? GMO crops using cryproteins. I'm not talking about the glyphosate resistant. I'm talking about the cryproteins. The cry is short for crystalline. These are crystalline proteins from BT, or Bacillus thuringiensis. These GMO crops the researchers found that these cryproteins can selectively kill particular insects. What was the first one? European corn borer. That's how it all started. GMO corn against the European corn borer. They genetically stuck in these cryproteins through the genetic code and started producing them in order to kill the European corn borer. And it worked. No European corn borers killed the corn anymore because they were killed by the cryprotein. Everything seems to work beautifully, or does it? Go out into the field. What are the European corn borers doing? Are they avoiding your plants? No. Are they still there? Yep, because they recognize the plant is unhealthy. Are they still laying their eggs? Yep. Hasn't stopped them. Are those eggs hatching? Yep. Are these little caterpillars munching on the corn? Sure are. Do they die? Yes, they do. But the plant is still weak. But you've solved the problem. European corn borer, gone. GMO crops, erased. European corn borer. What happened after that came out? We had a resurgence in Diabrodica, rootworms. Rootworms went after GMO corn that was designed to kill the European corn borer. First, they went after the corn earworm. That worked out really well, too, because a lot of these cryproteins works very well on the Lepidoptera, the butterflies and the moths. But then the corn rootworm, which wasn't as big of a problem, became a huge problem. Not an issue. Scientists got together and said, we'll just make another cryprotein, that is selective against Diabrodica. All the species of Diabrodica will take care of all of them. There are over 700 cry proteins that are out there. And they will insert one cry protein, sometimes two, sometimes three or more. And these cry proteins will be expressed in every single cell of the plant. So, if I've got GMO corn, it's supposed to go after the European corn borer, which feeds in the stem, generally speaking. It will kill it. But the toxin is in the leaves and produced in the leaves. It's also produced in the tassels and it's produced in the roots. Unnecessary for the European corn borer, but it's produced there anyway. Why are all these proteins being made? They're not being used to kill the European corn borer and the other parts of the plant. So what does that do to the plant? It makes it tired. All GMO cry crops are tired. You cannot raise them up to a high Brix because they're tired. Take a sick person and try to train them on that 100-meter dash. They will get tired. They're going to get even more tired in a marathon. They can't do it. You have created an impossibility. Let go of the bowling balls because it's not going to happen. Same thing with Diabrodica. Diabrodica only goes after the roots in the larval stage, but the cry proteins that kill it are found in the stem, the leaves, in the ear of the corn, as well as in the tassel. Totally unnecessary. It makes for a tired plant. And we have multiple insects coming in to attack that corn. We got many different varieties of GMO corn out there, as you are probably all aware. And you can get any formula you want. I want cry protein 1B, A2, XYZ. And then I'm going to order this cry protein and that cry protein in order to take care of your problem. And you create more problems because now you're putting weakened plants out. Low Brix, weakened plants that are susceptible. Still susceptible to the plants you're trying to kill, by the way. Still susceptible. All right. Soybean aphid. Soybean aphid. I would imagine all of you have heard of the soybean aphid. And yet, you probably don't realize that you had never heard of the soybean aphid when you were a kid. If I had asked you all when you were kids, if I could go back in time, in a DeLorean, and asked you about the soybean aphid, you have no idea what you're talking about. It's not much of a mystery. Chinese records state that soybean has been around for a long time, 11th century, so they must have been there. Soybean was introduced to North America in 1765. That was almost 200 years ago. Matsumura described the soybean aphid in 1917. The insect was there. It was known. It was described in detail and given its name in 1917. And yet, when the GMO soybean was introduced into the US in 1996, 3 years later, the soybean aphid appeared. Coincidence? I think not. Please understand that we are creating problems for ourselves. It is impossible. I haven't seen it yet. Someone can prove me wrong. To get a 14 Brix or higher on a GMO crop. They have all been compromised. The cry proteins I mentioned because they're tired. This is a little bit different. But this has weakened the soybean to such an extent that it is the #1 pest on soybean in some states. In other states, it's the second most important pest. And in still other states, it's third, but it's usually in the top 3 in every state that grows soybean. And 92 to 94% of the soybean is GMO. They're all weak, and the soybean aphid has exploited that. Yes?
Are you ever invited to any government conferences, agriculture stuff?
That is a wonderful question. Have I ever been invited to maybe a government conference or a Monsanto conference or a Syngenta conference, or have I been? It's funny you should mention that. Yes, I have, and it can be well received, believe it or not. Not by everyone. There are some who simply avoid. I was actually invited one time to one of these conferences. I was told to get my ticket. I said, I'll just wait, because a few weeks later, I said, I'm sorry, Tom, but you've been disinvited. And I said, really? I said, what's the reason? He said, I don't know. I mean, I just went through the trouble of inviting you, but the board got together and they just voted you out, so I'm sorry you're not coming. I'm thinking, wow, glad I didn't get that plane ticket. Probably not going to get the money back if I did. So I have been disinvited before. I've had that privilege of being disinvited to a conference. I do have a government conference coming up relatively soon. I won't say when, next month, and we're going to see how that goes. I'm not going to say. But yes. So unfortunately, I mean, I've been doing this now for a while. My name is starting to precede me. Not because I'm trying to be a jerk, but because I'm trying to release the truth. And there are some people who really don't like this, but I'm backing it with science. I'm giving you numbers, and I'm also explaining it to you as well. I'm just not getting up here and saying, these are the numbers, they don't lie. Just go ahead and do that, do exactly as I say. I'm teaching you, I hope, to think, to explain to you why this isn't working, this process is not working. Gustatory receptors, this is actually one of the things I do. I take a look at the chemoreceptors of insects to determine what they want to eat. And this is the soybean aphid. The soybean aphid these are the gustatory receptors, which are the taste receptors of the soybean. In other words, what does it like to taste? Olfactory receptors are what it likes to smell in the air. And there are also some other chemoreceptors, SNMPs and IRs and things like that, which I'm not including in this particular graph. This one is just showing the GRs. Okay? So this is a composite spectrum of all of the GRs combined, because I want to know what it tastes and what it's tuned to, because I have certain frequencies here. So I know what these are over here. These are the water peaks. I see these in all the insects that I analyze. So I'm not too worried about those. Some of them have differential abilities to detect water. That's another story altogether. But obviously, it's the big one. This is what you're all drawn to. You see there are a lot of peaks here, especially right here. But there's one big one that is sticking above everything else. That's usually what attracts your attention. It attracts my attention. And therefore, it behooves me, in order to figure out what is that peak. What is that 10,476 nanometer peak? What does it correspond to? I would like to know, because this is a clue as to what the soybean aphid wants. So if I take a look at that peak, and just that peak, I do a search, and I run across the infrared spectrum for ammonia. Ammonia has three main regions or peaks. Here is one right here with a nice hairline peak. Here's another one over here. It's a little bit broader. We have a lot of peaks around the center hairline peak as well. And then in this region, it's even bigger than the other three. So we've got three main regions of absorption in ammonia. If we take a closer look at the big peaks, the one where there are a lot of peaks, we can see that there's actually a doublet peak. It's not a single peak like here or here. I've got two. When I see a doublet peak, I realize, oh, this is a little bit more important. It's covering its bases. It's now got two peaks in this area rather than just one. What does that correspond to? That corresponds to, if I just look at the middle of those peaks and the range that it includes, that corresponds to 10,471 nanometers. There's a part of me right now that would like to explain the connection, but I think you're all seeing it right now. What is the soybean aphid going after? Well, my data tells me that it's going after ammonia. Seems to be very interested in ammonia. Is that the case? Let's take a look at the ammonium concentration in soybeans. So if I do a plant sap analysis, not the Brix readings that I do where I'm measuring the sugar, I'm talking about a plant sap analysis where they actually pull out the phloem and the xylem tissue of a leaf. Usually have to send it to a laboratory. We got a few laboratories here in the United States, Apical and New Age. Nova is where we often send our stuff. That's in the Netherlands. This is data from them. And in soybeans, we are looking at 10 to 30 parts per million ammonia. That's the range that we are looking for in soybean, just to kind of give you an idea of what a healthy range would be. By analyzing this plant sap data, we have determined that there are 471.1 parts per million on average. Sometimes it breaks 1,000, sometimes it breaks 2,000 parts per million. But on average, we're at 471 parts per million. And I didn't cherry pick this data. I've got 741 data points in this figure right here. I now have a correspondence. I understand better what the soybean aphid is going after. So when I tell you GMO crops are a problem because the soybean aphid comes in, you say, okay, I sort of get that, but I really don't understand. Can you give me more detail? I hesitate about giving more detail because I don't want to confuse you with numbers. But I felt at this particular moment, I would reveal this information to you. Certainly, I think you can handle it. But when you see that chemoreceptors say ammonia is what I need, ammonia is found in ridiculously high concentrations, and this GMO crop is unhealthy. It is not able to metabolize and prevent ammonia from building up. That's why these crops are unhealthy, and that brings in the soybean aphid. Hopefully you become a little bit more knowledgeable about that. We also have compacted soil. This is also a problem. Is it possible to get high Brix plants in compacted soil? No, it is not. You must open up the soil. As Mr. Rabenberg was saying, we're going to need some oxygen, among other things, because that brings in the aerobic bacteria. You need high mag soil is sometimes what compacted soil is called because there's a lot of magnesium in there, not enough calcium. Oxygen, highly paramagnetic and highly reactive. It's very beneficial to have oxygen in the soil, just from a biochemical standpoint. Yes?
My experience with hard soils is that the Brix are higher in general.
See? This is your opportunity to prove me wrong.
Well, and I think, and I've always thought that it's just that they're short and crappy, and they're just doing the best they can, but I often found on my really hard land that the Brix are higher, and they're not awesome, but they're higher. They're like 11, 10 kind of thing, and I don't know why.
I think I do. You just said hard land. How hard?
Like terrible, like just like really hard land where nothing's really growing very well.
Yeah. Yeah, you will get higher Brix on those circumstances. This is the exception that I didn't want to talk about because I don't wish to confuse. But when you have very, very dry soil, you have less water in the soil, you have less water in the plant. When you have less water in the plant, you have a concentration of the sugars, and you get an artificially high Brix readings. Lauren is shaking his head back there because both of us remember that phone call from a few years ago. And you need to add water to that plant, just choose a plant, in order to find out what the Brix really is, because it's artificially high because it's all dried out. So these are some of the nuances that I didn't want to introduce because I don't have a lot of time to get into it. But you brought it up, so absolutely. In dry crops, you can have artificially high Brix levels, and there are little games that will need to be played in order to determine what the true Brix is. Yes?
The slide before, so if these genetically modified plants there's more ammonia in them, for the people that are trying to move their way out of these GMO crops and just go farming, would we be better to not put 120 pounds of nitrogen on? Like, would it be better to step it out through the year? Would that help that problem?
Yes, it would be better. The question is, should we step out of high nitrogen in order to correct the problem? Because the plant is not healthy, which we understand and we test, and therefore we want to feed the plant. So we, unfortunately, put down NPK fertilizers, making the problem worse, but it temporarily feeds the plant because you stuff it. High conductivity, NPK fertilizer, shocks the plant, throws the nutrients in, causes it to green up, lasts for a day or two or three. By the time you get to a week, the plant is starting to suffer again, and you need to shock it again with another NPK fertilizer. You then get a drug addict. It becomes dependent upon that because it's no longer feeding itself. So yes, we need to work away from that, but there are a number of things that will need to be done. I'll probably have to talk to you afterwards about some of the things that could be done. The lack of oxygen is severe as far as the aerobic bacteria. You should have an 80-20 relationship. You should have 80% aerobic bacteria, 20% anaerobic. You always need to have some anaerobic bacteria. But sometimes it gets reversed. It's 20-80. And your soil's not healthy, and your plants will reflect it because the microbes need oxygen. And the reason why they need oxygen is so they can feed your plants those minerals that I just got finished telling you is what you need for a high Brix plant. Here's a complete idiot in a white shirt talking to two people who know a lot more than he does, because I have to learn. So there's a consultant right there in the hat. That's the owner of the flowers right there. All plants grown in a greenhouse are UV deficient. So if I'm going to go into a greenhouse, they're all deficient in UV. And because they're deficient in UV, if that's important, they're going to be low Brix. And they are. They're always low Brix. Anytime we're in a greenhouse, I would always suggest, well, we have to start there. I would say, good, then do it. But get them out of there as fast as possible. Unless you have a roof that opens up, that will allow the sun to go inside and actually feed the plants some of that UV energy. Don't need that much of it, but you do need some. Why do I mention this? Greenhouses have their place, but if you have the ability to open it up, the plants, first chance they get, will spring for life, and they will try to get that sunshine in order to health up high Brix themselves. Common amino acids. Why do I bring this up? There's about 20 amino acids. Of those 20 amino acids, I'm not going to focus on all of them. I just want to focus on 4. Phenylalanine, tryptophan, tyrosine, and cysteine. These 4, and only these 4, are UV absorbers. The other 16, inconsequential. They're about as close to 0 as you can get. But these 4 absorb UV. It is important to get a little bit of UV for their health. Why are these 4 more important? I mean, it's just 4. Can't we just substitute the other 16 and still get a complete protein without these 4? No, you can't. Due to the energy absorption in proteins, ultraviolet absorption is important because it's absorbed by almost all proteins. They all have tryptophan, tyrosine, and phenylalanine. And of course they have cysteine too, but it's only in the disulfide bond, which means you need 2 cysteine molecules. It's only the bond that is absorbent at 125. By themselves, they're pretty much at 0. When they make that cysteine residue bond, they're up to 125. Not that high, but it's casually high. Tryptophan, skyrocket high, 5,600. Tyrosine, 1,400, very, very high. What is the importance of these amino acids? Did you know that glyphosate kills plants by interfering with the synthesis of the essential amino acids tryptophan, tyrosine, and phenylalanine? This is another one of those times I have to make the association because people are not reading up and down the slide right now. Glyphosate is doing almost exactly the same thing that is happening inside the greenhouses. It is compromising those 3 amino acids. It is compromising the production of those amino acids. And when they are compromised, the plant health goes down badly because the insects that are attacking in the greenhouse are at the lower end of that scale. Think about it. What's attacking your plants in the greenhouses? Whiteflies, aphids. These are all the sucking insects that are in there with very few exceptions. They're going after very unhealthy plants. So greenhouses have their place, but some modifications need to be done. It doesn't matter whether it's glass or whether it's with the plastic, polycarbonate plastics that are out there. They're still 97 to 99% absorbent of UV. And so this is a problem. Glyphosate knows it's a problem, and that's what it takes advantage of by taking care of those 3 amino acids. So you want those 3 amino acids to be there, and you want them to be happy and healthy. The leaf canopy is also a factor as we're getting near the end. So I got a few more slides before lunch. The leaf canopy is a factor too. Why? Because the roots like to go down usually about the distance of the leaf canopy and no more. Sometimes they can go a little bit further, but the vast majority of them are located under the leaf canopy. So you'll find the roots of a big tree going down 10, 20, 30 feet or more. Sometimes you could have a tap root going down 100 feet or more. I think they've had 400-foot tap roots are some of the records that they have. But generally speaking, 30 feet or more for a big tree. But not so in Florida. Because in Florida, we may have the same amount of soil, so to speak, but we've got a problem. We've got a water table. And the water table comes up pretty darn high. And so we don't have roots that are going down that deep, because roots don't like to be submerged. And so because of that, we have our trees spreading out their roots, and the roots are now found much more spread out and much more shallow than it was before. This means that if you start planting trees too close together, their roots will intermingle. And when you compromise the roots, 2 things are going to happen: fungus infection on your roots and insects attacking your roots. Because the fungus and the insects are only going to be going after weakened roots. And so we have high density planting. If you've been down to Florida a few decades ago, you may have seen a citrus tree, gigantic, huge. They would have 40 to 60 in an acre. Now, they look like bushes. Those are citrus trees. They look like a whole bunch of bushes. They grow into one another, the roots grow into one another, the leaves grow into one another, and you now have compromised plants, compromised citrus. And when it's compromised, this brings in the insects. Asian citrus psyllid, citrus greening, because we're now at the point right now where citrus is grown as a hedge. There's nothing healthy about this at all. Yes?
Now, you're just talking about one single plant.
I am.
Crop. How is it when it's a multi-species?
When it's another species?
Yeah.
How about corn?
Combined together.
Okay, let's talk about corn. Corn is relatively healthy when it's running about 18,000 per acre. Some of you are probably laughing at me right now, saying, do you realize we're double that right now? Yeah, you're about 36,000 to 40,000 plants per acre. That's also high density planting. And when you have the corn plants growing into one another, their leaves do overlap one another. I've been in the fields. You've been in the fields. The roots are overlapping one another. They are compromised, and this brings in the insects. So in order to take care of the insects, you either have to spray an insecticide, or you have to go get some GMO corn with the right cry protein. So thank you. So yes, that was just oranges, and I just brought up corn. It's applicable to all of the other plants too. They need a little bit of room to breathe, just a little bit of room, and then they're healthy. And when they're healthy, you're putting less inputs on. And when you're putting less inputs on, that's more money in your pocket. Yes?
And if I have, let's say, a polycropping, what's the interaction? If I have, let's say, corn, soybean, peas, or everything combined in the same field, what's the reaction then?
It depends upon many different things. Do the roots intermingle with one another? Yes. Is that potentially problematic? Could be, because some roots work well together. Some do not. There's companion planting. And so therefore, if you put out different plants, they work well as companions. So that's a question that I cannot answer definitively, because sometimes it's problematic and sometimes it's not. Generally speaking, it's pretty good when you've got a variety of plants, which is what you do with a cover crop. If you go out with a cover crop, you're putting out 15 to 20 different seeds, and therefore you get a lot of action going on, and they're not competing with one another as much because the plants are so different from one another. Yes?
This year, we did an experiment with corn interplanted with soybeans in between.
Mm-hmm.
And it looked great from satellite photos and everything else as far as vegetative cover. But in the end, across the weight cart, we actually had a yield penalty on the corn where the soybeans were.
A yield penalty, meaning you did too much?
Poor yield on the
Oh, lower yield.
Yeah, which
Okay.
we're scratching our heads on.
Yep. Wouldn't be able to answer exactly why, but some companion planting works. Obviously, the reason why you did that is for one thing, and you know it and I know it. It's nitrogen. That's the reason why it was done. But we're ignoring all the other factors that may have been a factor too. So exactly what was going on, I'd have to take a look, and measurements would have to be made, because I don't like to guess if I can help it, being the dumb scientist and everything. All right, so here's just a repeat of that last one, so you understand that different insects are attracted to plants based upon their health levels. So I just wanted to mention that one more time, just to keep it in your memory banks. And I wanted to point this out again, because this is the slide that sold Cindy. When I was talking to her on the phone, she wanted to get this out. This information is now out. I now have a target on the back of my back, and I will deal with whatever it is that people are going to throw at me, including next month. All right. Thank you so much for putting up with me.